Section Coism is not there. Section Coism. No, next roll number 29. Mayank is there.
Yes, ma'am.
Mayank, you can start. Timeline chart with example.
Yes, sure, ma'am.
Okay.
Am I audible to all?
Yes, okay. It is audible to me. I don't know about others.
Okay. So, good afternoon, class. So, topic assigned to me is timeline chart with example, and I'm proceeding further. So, I think my screen will be visible to all. Is it so?
Have you say
Anyone
yeah,
can?
yeah, it's visible now.
So, let's have an overview about timeline chart. So, basically, a timeline chart depicts how a set of resources can be used over a time. So if we are managing such as like a software project, or if we try to illustrate what we are doing and when we are doing, so in that thing, a timeline chart is very useful, and it was invented by Henry Dent in 1917. Now coming to the definition of timeline chart. So basically, a timeline chart is a visual rendition of series of events. It can be created as a chart or a graph. Now coming to the types of timeline chart, there are basically three types of timeline chart. First one is a standard timeline chart, second one is Gantt chart, and third is time series graph. Now we will focus on the timeline chart which is of a standard type. So only first type will be illustrated here, and we don't need to go deep in the other two. So what are the uses of timeline chart? So it helps us to manage and keep the complex tasks on time. That means if we try to do more complex tasks and we are trying to do within a deadline, it will be more useful to use the concept of timeline chart. And it also helps us to visualize the process or event that took over a period of a time, and allocation of resources becomes less hectic or more easier in this way within a certain deadline. Now coming to the steps for making a timeline chart. So steps for making a timeline chart is, first we select any event or process, then we represent on our timeline. We select our beginning date and we point out our ending date. If in there is there any important date or milestone, we mark them as well, and we do all the processes in chronological order. And the spacing is taken care like within a period, suppose we are marking 5 days, then it should be looking like a 5 days. If we are marking a 10 days, then it should be double of the space taken by 5 days. Now coming to the key features of timeline chart. So am i am I audible to all? I think anyone can answer. Okay. So coming to the key features of timeline chart. So all projects are listed in far left column. That means we are starting from left and going till right. The next important point is few columns may be listed as each for each task, like project start date, project stop date, project duration, actual start date, actual stop date. These are just like the important points which are to be marked on the timeline chart. And one more important thing is there, it is called predecessor. Like it keeps track on how the processes are taking place, like one after another. We are uh, using predecessor concept to mark on that. Now coming to the, yes, the length of horizontal bar indicates the duration of the task. And last point is diamond shape is represented as important milestone or important duration of that specific task. Now coming to the example, so I've taken MEMS example only. So here, so suppose a task is starting from a date 1st of January, and it's ending, and duration of this task is 2 months. So it is supposed to end by February, and it is having none as predecessor. So this will continue on the timeline chart as like this. And suppose we have another task, suppose we have a milestone at named as n. So its duration is 0, and it's starting from, suppose it's starting from 3rd of January, and it's finishing on 3rd of, wait, it's I think it's March. Okay, so it's starting from, it is on only 1st of March. So it has predecessor as 1, and what we do, we just mark down that diamond shape on the 1st of March, and that will do our diamond shape milestone marking. Now coming to the example that we did in our class. So suppose we have certain processes and duration is given, and we have certain predecessors. Now how do we mark down? So now coming to the A. So A has none predecessor. So suppose it is starting from the 1st of July. I think it's June. Okay. So suppose it's starting from 1st of June. So it is supposed to end within a 3 days. So it will go till 3rd of June, and it is having none as predecessor. So we mark down the spacing like for 3 days. Now coming to the process B. So process B is running till 4 days, and it is having predecessor as A. So we will start where B has ended, and we will mark down the 4 days length. And so it will suppose start from 4th of June, and it will go till 7th of June, and it is having a predecessor as A. Now coming to the process C. Now process C says it has a duration of 3 days, and it has a predecessor as B. Now we will mark down wherever B is ending, we will start C from there only. So C is having a 3 duration days, and it is starting from 8th of June, and it is going till 10th of June, and its predecessor is B only. So we will mark it just like that, and we will mark a length of 3 days on the timeline chart. Now coming to the process D, and it has 3 days as duration, and predecessors are A and B. Now predecessors are A and B. We will check like, so it will be starting from 8, because A and B we will consider whichever is recently finished. So by that way we will start from 8th of June, and it will go till 10th of June, because it has a duration of 3 days. So D will start from 8, 8th of June, and it will go till 10th, and we will mark on this on the timeline chart. Now coming to the process E. Process E says it has a duration of 4 days, and its predecessor is C and D. So we will check whichever has ended recently. So process D has ended recently, so we will take just 1 day after it as a starting point for the process E. So D has ended on 10th of June. So process E will start from 11th of June, and it has a duration of 4 days. So it will go till 14th of June. And what are the predecessors? And C and D are the predecessors. So we will mark that accordingly on our timeline chart. Now coming to the process F. So process F says it has a duration of 10 days. And what are the predecessors? Predecessors are C and D. So recently E has been finished. So E has finished on 14th of the June. So we will start process F from 15th, and it is having a duration of 10 days. So it will go till 24th of June. And what are the predecessors? Predecessors are C and D. So we will mark accordingly. Now coming to the process G. Process G is also having a 10 days of duration, and its predecessor is F. So it will start just after the F is finished. So F has been finished on 24th of June. So G will start from 25th of June, and its predecessor will be F, and it has a duration of 10 days. So it will go till 4th of July. So we will mark that accordingly on our timeline chart. Now coming to the process H. Process H says it has a predecessor of G, and it has a duration of 8 days. So we will go on the process G, and it has a predecessor, I think H it was, sorry. So yes, process H it is. So it has a predecessor as G, and it's a starting where after like G is ending. So G is ending at 4th of July. So we will start our H from 5th of July, and it will go till 8 days. It will run till 8 days. So we will end this at 12th of July. So we will mark that accordingly on our timeline chart. Now coming to the last process, and last process is I, and it has a duration of 5 days, and it has a predecessor as G and H. So recently H has been finished, so we will start I from just after the H has been finished. So H has finished on 12th of July. So our I will start from 13th of July, and it will go till five more days. So it will end on 17th of July, and it has a predecessor of G and H, and we will mark that accordingly. That concludes our timeline chart. Thank you all for listening me with patience. Is that
Okay.
clear, or if anyone can ask any question, that would be better.
Anybody is there who wants to ask anything? So here in your this timeline chart, what is important is we need to know the predecessor. Okay, predecessor is important so that we can continue. We can mark our number of days. Okay, so that is important for timeline chart, and that predecessor is again important for uh, finding your critical part also. We can associate with critical part calculation also. But for Mayank, only timeline chart representation is what I have assigned. So for next one, roll number 36, FP calculation, function point. Mayank, very good. So next, I'm going to call roll number 36.
Thank you, ma'am.
Okay.
Yes, ma'am. Roll number 36.
Okay, 36, you
I
can
hope,
start your presentation.
yes, ma'am. I hope that my screen is visible and I'm audible. First of all, I'm sorry for using the phone. It's a little bit uncomfortable for me to use the laptop because there's network problems here. Uh, so let good morning, everyone. First of all, uh, today I'll be orchestrating a presentation on the topic of function point calculation, and I'll be providing a soft example for the same. First of all, let us just go over some points that we would be covering in this presentation. Here, first of all, I'll just give a brief introduction about function point, just so as to be familiar with what we are calculating for, what we are trying to solve. After which we'll go for steps of calculation. We'll be seeing the various steps that we will need to follow in order to calculate our function point. After which we'll just go part by part into the function point calculation. We'll be having two major parts. Function point is calculated mainly by first we need to find our value adjustment factor, after which we will find our unadjusted function point. The multiplication of these two values gives us our function point. That is how we know. And so I'll be going over as to how we'll be calculating, as to how we'll be finding out each of these values. And then at the end, we'll be seeing a solved example, which I have selected. So first of all, before jumping into the solving problems, we'll look into what we are solving for, that is our function point. Uh, Based on what we know about function point, as to the definition, function points measure software size by quantifying the functionality provided to the user based solely on logical design and functional specifications. Now, in simpler words, function point is a sizing measure of clear business significance. It helps us in obtaining and in quantifying the functions contained within a software in terms that are meaningful to the software users. Since this measure is directly related to the business requirements for which the software is made, it can hence be readily applied across a wide range of development environments, such as determination of cost or time consumption factors and workload. You see, this is a method that does not rely on any particular technology or computer language, and so it is of great help for various application development projects. So first of all, we'll look into how we can find out this function point. The steps of function point calculation. First of all, we need to determine the type of count, then identify the scope and boundary of the count. Then after which uh, these two steps will be then used to determine our unadjusted function point count. Once we find our unadjusted function point count, we will keep that aside and we will calculate for our value adjustment factor. Once we get both of these values, we will just multiply them together to find our adjusted function point count, which is our final result. Now for counting our function point, this is the first step for calculating unadjusted function point. First of all, we have 5 parameters or information domain characteristics that we will be looking into for determining our unadjusted function point. These 5 parameters are number of external inputs. Now, these number of external inputs, these include like data entry by users or data or file feeds by external applications. Then the second parameter is external outputs. These include reports created by the application that is being counted, but these reports should include derived information. The third one is external inquiries. Now these include reports created by the application again, but this time the report should not include any derived data. The fourth one is internal files, or as you can say, internal logical files. These include like tables in a relational database or flat files or application control info. Then the last one, the fifth parameter, is external interface files. These represent data that the application will use or will refer to, but this data is not maintained by the application. These information domain characteristics are again identified based on again assessed individually for complexity. This we will see in the next slide. So now that we have our 5 parameters, we will be given individual complexities for each of them, as in we will be given a value for each of these individual parameters. And again, these individual parameters are assigned weights, which are experimentally determined. Complexity is essentially how much value each of the information domain characteristics deserve based on experiments. And these weights are multiplied to the aforementioned functional complexities individually. And then each of these individual results are then summed up to determine the needed unadjusted function point. As in, let us suppose that we have our weighting factor as high. Then in that case, we will be given, and along with that, we will be given each of the complexity values for each of the parameters. Then what we will do is that we will take the complexity value of external inputs, let's say, and then we will multiply that with 6, which is the experimentally determined high value of external inputs. Likewise, we will do the same thing for the rest of the parameters. We will take the complexity value of external output, we will multiply it with 7, then we'll take the complexity value of external inquiries, we'll multiply it by 6, and likewise for internal files and external interface. After we get each of these individual results, we will add all of them, and that summed up value is our unadjusted function point. Now, since we have gotten our unadjusted function point, we have found one part of our final result, which is this unadjusted function point. Next, we will need to calculate for value adjustment factor. Now, value adjustment factor, it can be calculated by the formula total degree of influence TDI into 0.01 plus 0.65. Now, this total degree of influence is actually like unadjusted function point is still at the end of the day unadjusted. It is still not exactly what we want. It is not the precise value that we need. It is still uncalibrated. So for further calibration, for further adjustment of this roughly obtained UFP, we need to have some other value which we will use. Now for this calibration, we will be using a set of 14 general system characteristics that are considered for this adjustment. Each of these 14 general system characteristics will have its own individual degree of influence, as in how influential they are in changing the UFP value that we have received before. This degree of influence is assessed on a scale of 0 to 5. That is 0 being of no influence to 5 being essential. Now, each of these 14 GSCs will have a value from 0 to 5, and then we will be having 14 of these values. So altogether, we will be adding all of these 14 values, and that summed up value is our total degree of influence. So now, since we have our total degree of influence, we can find our value adjustment factor by multiplying that value, that total degree of influence, to 0.61 to 0.01, and then adding it to 0.65. Like I said before, in this current slide, we can see that the value adjustment factor is computed from the value of total degree of influence using the following formula. VAF is equal to TDI into 0.01 plus 0.65. Now, let us consider that these 14 general system characteristics have absolutely no influence to our UFP. So in that case, the scale value for each of these 14 GSCs would be 0. So if that were the case, then our total value of TDI would be 0, because TDI is the summed up value of these 14 values. Since all of them are 0, our TDI will be 0. Then if TDI is 0, our value adjustment factor will be at the least 0.65. It cannot go lower than that because TDI at the least can be 0. Likewise, if our TDI is at the max value, that is, it has a maximum influence towards our UFP, that means all of the GSCs, all of the 14 GSCs have a scaled value of 5, then our TDI will be 70, and our VAF will have the maximum value of 1.35. Now, our final function point calculation is determined by multiplying this value adjustment factor and our unadjusted function point. Now, I'll be showing what I just talked about in a short example. I did not choose any complex example. It's a rather simple one with minimal numbers, because more numbers will make it confusing. First of all, we have our 5 parameters, as I said, and we have these individual values assigned to us, these are what we will multiply to our weighted value of each of these parameters. So now uh, we have 45 for UI, 40 for UO, 37, 8, 6. Yeah, I'm just noting it down. So for finding the result, let's read the question first. Sorry. Uh, Given the following values, compute the function point when all complexity adjustment factor and weighting factors are average. So now we know that these values, complexity adjustment factor and weighting factors, are average. So this will be important in the question. So now we were told that our complexity adjustment factor was average, which means that in the scaling that we have, let me just go back real quick. In the scaling that I had shown before, average is 3. Based on this scale, 0 is no influence, 1 is incidental, 2 is moderate, 3 is average. So we have our scaled value as 3. Now, I had told that this scaled value, there are 14 of these values. So if we were to find out that each of these values is of the scaled value 3. So if we were to find our TTI, which is the sum of for these 14 values, we will be adding 3 14 times. That is 3 into 14. So our TTI is 3 into 14, that is 42. Now we have our TTI. So with our TTI, we can solve our value adjustment factor. So for finding value adjustment factor, we multiply this TDI with 0.01 and we add 0.65 to it and we get 1.07. So now that we have our VAF, our only thing left is to find our unadjusted function point. Now, unadjusted function point was determined by multiplying the weighted values to the individual values given in the question of the 5 parameters. So now again, the weighting factors were also given as average. So now if we go back in this to the previous slides, we will see that for average, these are the values, these are the weighted values for each of the parameters. For average, there's 4, there's 5, 4, 10, and 7. Now, keeping these values in mind, we will go back to the question. And in this question, we were to multiply the assigned values, the individually assigned values for each of the parameters with each of these weighted values. So now our UFP will be the value given for user input 45 into 4, right? Then plus the value assigned for user output 40 to into 5. Likewise 37 into 4. Likewise 8 into 10. Likewise 6 into 7. This will give us 650. 650 is our unadjusted function point. Now we have our value adjustment factor, we have our unadjusted function point. So our final function point is given by a multiplication of these two, which is 695.5. This is the required answer. Yes, this is where I'll end my presentation. Thank you very much.
Okay, so anybody wants to ask anything to Vivan? Vivan, you can include a calculation for that one also, which we have the number of pages, number of documentation, cost, all the other parameters can also be included. Okay. So
Okay, ma'am.
from FP calculation, not only FP, we can also uh, find out those other parameters like number of documentation, number of pages which I have given you, and cost also you can find out, productivity also you can find out. So all those parameters are also important for your exam. Okay. So very good, Vivan. So next one, after Vivan, we will have roll number 53, software testing strategies. 53. Is 53 present? Roll number 53 is there in the group, in the class. Roll number 22 is there. Project scheduling. Roll number 22, Jackson. Jackson Akoizam is there. Next, roll number 62 is there.
Yes, ma'am.
Okay, 62, you can start your presentation. Risk management.
Okay, ma'am. Ma'am, is my screen visible?
Yes, yes, it's visible.
Okay. Good afternoon, class. Today we are discussing about risk management. A risk is anticipated unfavorable event or circumstances that can occur while a project is underway. So, if a project is starting and if any risk is going to appear, it is in the underway. If a risk becomes real, means if you identify risk, it may become real or unreal. If it come into the play, it becomes real, which have adversely efforts on the project and stop the successful and timely completion of the project. That is does the stopping of the project, right? And anticipation the identify different risk of the project is suspectable. To identify the risk, we are categorizing the risk into different groups, which is done in three ways. Risk management consists three essential activities: risk identification, where the identification of the risk takes place; risk assessment, and where the assessment of the risk means how much the probability of risk happening in the project can appear, or like risk mitigation means to decrease the severity of the risk. Okay, let's see the risk identification. Risk identification is the possible impacts of the risk is minimized. So finding the risk early is important to minimize the risk effects on the project. In order to able to systematically identify the risk which might affect the project, it is necessary to categorize risk into different classes. So of risk is divided into three classes, which are mainly uh, in software project is project risk, technical risk, business risk. Project risk are the risk that appeared in the project, such as scheduling or resources, something like technical risk, or appeared in the technical management. For suppose if quality of the uh, workers or the newcomers have done any mistake, those risks are taken place in technical risk. And business risk, if the product is gone to market and if you don't have good market to make it, there those risks are comes into business risk. So we will see first project risk. Project risk concerns various forms of budgetary schedule, personal resources, and customer related problems. These risks are not seen by someone else, right? It is very difficult to control this something which can't be seen. This risk can't be seen by Nick, right? So it should be risk or schedule slippage. It may takes the project to deliver beyond the schedule, which stops, right? And the second one is technical risk, concerns uh, potential design, implementation, interfacing, testing, and maintenance problems. Most technical risk occurs due to Development in insufficient knowledge. Insufficient knowledge means if we don't have knowledge or experience in the team, these risk appears more. And business risk of building excellent product that have no one wants. If no one wants, no one buys. There will be business risk and losing budgetary commitment, etc. Next item is risk assessment. Here we will do the assessment of the risk. That means how much probability the risk will appear in the project, or how much severe is the risk to that project. The object of risk is to rank the risk in terms of the damage causing potential, right? And likelihood of the risk becomes real. It is means a probability. Probability the risk will be real. The consequences of the problems associated with the risk. Consequences associated means severity. How much strong the damage caused by the risk. And we have the problem P equal to R into S, where P is the priority with which the risk must be handled, and R is the probability of the risk becoming real, and S is the severity of the damage caused due to the risk becoming real. And we have a third one is a risk mitigation. Mitigation means to make less severe uh, in something bad way. Plans are made to contain the most damaging and most likely risk first. So if you have any most damaging risk or most likely it appears compulsory in the project, so you have to plan to first attempt the risk to minimize the risk which is causing most damaging or most likely to have which have more probability. So there are three main strategies for risk containment. Avoid the risk. Risk often arises due to the project constraints that can be avoided by suitably modifying the constraints. Modifying the constraint, if you have any constraints, something like if you have to project to work in this way, if you minimize the constraints to work with the efficiency of 70%, if you are avoiding the risk, so it can be good, right? Project related risk. These risks are arise due to aggressive work schedule, budget, and resource utilization. If you have very tight schedule to do that, these risks will be avoid. We have to avoid with very aggressive work schedule. Project related risk. These risks arise due to commitment to challenge. If you are committed to challenge, if you are going to complete the product within a given prototype within 1 month or 1 week, there will be very aggressive work schedule where these risks are most probably. And product features and quality and reliability and technical related risk. These risks arise due to commitment to use technology. If okay, if you are technological related risk means if you are designing a mobile phone, if you are using going to use 5G, if you are going to create a 5G mobile, which is very competitive, right? If, even 4G is not even in much cases, it will be using these technical related risk. These causes something like, for example, satellite communication using very more accuracy phones like that. Transfer the risk. It is another matter. This strategy involves getting risky components developed by the third party, buying insurance cover, etc. Okay, these can be covered by if you have any something, if you have designed the product, this can be transferred. If you have any insurance before of the product, if it is damaged, it can be covered by the insurance, right? So these are the transfers. These are placed in the category transfer of the risk. And risk reduction involve the planning ways to contain the damage to reduce the risk. Reduction means reducing the risk outright. The most important risk reduction technique for technical risk is to build a prototype that tries out the technology that you're trying to use. You must plan the prototype that tries out the technology that you're using it to make a prototype. Important risk reduction technique is to choose the most appropriate strategy for handling the risk. The project manager must consider the cost of handling the risk and corresponding reduction of the risk. So you have to design a prototype such that project strategy for handling the risk, and project manager must consider cost of handling the risk and corresponding reduction of it. So the prototype should work in three ways: for handling the risk, and cost of handling, and the corresponding reduction of the risk. You have to design that type of prototype. Risk leverage is the difference in risk exposure divided by the cost of reducing risk. So we have a formula here: risk leverage is equal to risk exposure before reduction minus risk exposure after reduction by cost of the reduction. So that's it. Hello, ma'am. That's it, ma'am.
Yes, yes, yes. So anybody, if you want, you can ask him about the risk management. So normally in risk management, the RMM plan is important. Okay, and that is where I will be asking questions in your examination. RMM plan. So risk mitigation, that monitoring, maintenance, and management. Okay, so okay, call number 62, Lakshmi Narayan.
Thank you, ma'am.
Okay, so roll number 22 is still not there. 22, 22 is not there. And who was the other student? Roll number 50 something, no? Just a second, let me check. Roll number 53, Sweta. Sweta is there. Sweta Chaudhary is there. No. Roll number 1 cannot present today. Roll number 22 is absent. I think that's all then. Roll number 29 presented. 36 also presented. 52 also presented. 53 is absent. 53 and 22 they are absent. One he is unable to give the seminar today. Okay, so let me take a quick roll call then. So in Kokomo model also, uh, just I will give a small revision about Kokomo model because I don't think we will be getting other classes for your for revision. So in Kokomo model, we have three basic models. Okay, one is three different models are there: basic model, intermediate model, and detailed model. And also we have three types of projects. Three types of projects, or else it is known as development modes. Three modes. So the first mode or the first project type is organic, second one is semi-detached, and third one is embedded. So we have these three types, and for these three types corresponding formulas are given for finding out your effort and time development. So for organic, different formula. For uh, semi-detached also we have a different formula, and for organic also, oh sorry, for embedded also we have formula for effort and development time. And sometimes the parameter values may not be given, so you need to learn by heart. That means the exponential parameters, okay, the coefficients and exponential parameters that may not be given. So you can just learn by heart for that one. Sometimes it may be given in the question, sometimes it may not be given. The three types of projects are there in COCOMO model. COCOMO is nothing but constructive cost model, okay, estimation model, constructive cost estimation model. And example calculation, we have example calculation. Normally we will be using source lines of codes, source lines of codes, that is size matrix, that will be used for finding out any effort or development time development for the corresponding project types. And once if you calculated effort and time, you can also find productivity, you can also find average number of persons. Okay, that is about COCOMO model. And software testing strategies, this one last class we have done. So we study different types of testings in software testing strategies. For example, unit testing is one important type of testing strategy where unit modules, single modules are being tested. And also we have other testing types. We have integration testing, we have validation testing, we have system testing. And other types of testings are also being discussed. For example, in integration, we have two types of integration testing: non-incremental integration testing, incremental integration testing. Okay, again, in non-incremental, in incremental integration testing, we have another three kinds: top-down integration, bottom-up integration, and sandwich integration. So top-down, as you know, the approaches will be started, the program will be uh, test constructed from the top until down. So it will move towards downwards. So we have top-down integration. So here in top-down, the modules will be integrated by moving downward. Okay, by moving downward, starting with the main module. So starting with the main module, it will be integrated into sub-modules and it will move downwards. That is top-down. Similarly, for bottom-up integration, integration will be started with the most atomic modules. That means from the downward sub-modules, it will be started and it will be moving upwards. That is bottom-up integration. And sandwich, where we have combination of both top-down and bottom-up integration. So we also have smoke testing, regression testing, and we have validation testing, we have alpha and beta testing. So alpha and beta testing is important. So alpha testing is conducted at the developer's side by end users. And also beta testing, it is conducted at end user's side. So here developer is not present in beta testing. And we have other system testing types. Recovery testing is one type of system testing. Security testing, where it verifies the protection mechanism. Stress testing and performance testing also we have under system testing types. And finally, we have debugging. We have debugging process where we will find or we will uncover the errors in debugging process. And we have three strategies for debugging. They are brute force, backtracking, and course elimination strategies. Okay, so that with that your strategies, testing strategies is completed. Okay, so I will take your roll call for today, and if we get any chance, we can continue our this revision for using this seminar. Otherwise, if we don't get any chance, we will be completing by today. Okay. So anyway, if you have any doubt in between, you can ask me anytime, but not at night time. Okay, from daytime, morning, from 10 o'clock until evening 5 o'clock, you can ask me any doubts in any examples of software engineering, in theory or in problem or anything. Okay, so morning from 10 o'clock until 5 o'clock, you can ask me if you have any doubts regarding the subject. Okay, so that's all for software engineering. We will complete for today, and our rough revision is also completed. So roll number one is absent today. Roll number two, Akash.
Present, ma'am.
And if you haven't submitted your assignments or anything which I have given in the Google Classroom, you try to submit before your end term, okay? Because all those will be counted for your internal marks. Any assignments which I have given, any thing which I have asked you to submit through your Google Classroom, you try to submit before your end term. Roll number three, Atul Sharma. Absent. Roll number four, Sorin Tree. Absent. Roll number five, Manikanta. Absent. Roll number six. Roll number seven. Seven. He has informed me regarding content. Okay. Roll number eight, Daya Sagar.
Present, ma'am.
Roll number nine.
Present, ma'am.
This Sweta is another. Okay, okay. That was roll number 53, Sweta. Roll number 10, Yaswan.
Present, ma'am.
Roll number 11,
Present,
Chaitanya.
ma'am.
Okay. Roll number 12, Harish Kumar.
Present, ma'am.
Roll number 13, Devi Sri Shankar. Absent. Roll number 14, Helen Banet.
Present, ma'am.
Roll
14
number
present, ma'am.
15, Deepak Kumar.
Present, ma'am. Present, ma'am.
Okay. Roll number 16, Herojit Kharibam. Roll number 17, Janendra.
Present, ma'am.
Roll number 18, Abhishek Huidrom.
Yes, ma'am. Present.
Roll number 19, Jagdeep Singh. Roll number 20, Emmanuel.
Present, ma'am.
Roll number 21, Keshav Kumar. Roll number 22, Jakshana Poison. Yes, absent. Roll number 23, Kora Pravin. 24, Nishita. 25, Ganapati.
Present, ma'am.
Roll number 26, Levisha. 27, Manjit. 28, Lumaulen Lufo.
28 present, ma'am.
Roll number 29.
Present, ma'am.
Roll number 30, Magdalene. 30, absent. 31, Sai Sri. 32, Mangalsana.
Present, ma'am.
Roll number 33, Nela Kartik.
Present, ma'am.
34 Suchitra,
Present, ma'am.
35 Niket Kumar, 36 Jivan,
Present, ma'am.
37 Vishnu, 38